we have two major formulas left for us to take a peek at on our objectives. That's going to be the future value of an annuity. I mentioned on Friday, annuities usually, I mean, the most useful kind of annuities are lawsuits. You know, you win a lawsuit, somebody owes you $30 million. Nobody has $30 million laying around to say, here's your $30 million. So they set up a payment plan, and those are annuities. And then find the monthly payment or term of investment. That's going to be more along the lines of we have to take out a mortgage, and we want to make sure things are being calculated correctly, or we buy a vehicle, because again, most people can't just pay cash for a vehicle. And when you have to buy a vehicle, for a lot of people, is usually kind of a surprise thing. You know, somebody gets into an accident, so you need a new vehicle, that kind of thing. So the different things we'll talk about today, definitely consumer issues. You want to make sure that you are paying what you're supposed to pay. An annuity is a sequence. Please wake up, smartboard. There you go. An annuity is a sequence of equal periodic payments. They figure out, well, you order $30 million. How are we going to make that happen? And talk about the payments based on what the value would be at the end of the time period. This has to be fair. If the person were to get the $30 million right now, they could probably just live off the interest to that $30 million for the rest of their life. But you're taking that away from them, bless you, by making it in payments. So you can't just take the $30 million and divide it by how many ever years it's going to take to pay it back. You also have to consider the interest that would be lost. The annuity is ordinary if deposits are made at the end of each period at the same time the interest is posted in the account. So ordinary interest is the most basic type for us to figure out ordinary annuities. And that's because we're setting things up so that they get money at the end of each quarter for the interest, the end of each semi-annual period, whatever it is. So this is not a special situation, which would be they start making the payments in April, and payments are supposed to be done quarterly. We're not going to jump to any of that. The formula has enough in it without that we don't need to start talking about, okay, it was a portion of the quarter that they got it for. So we're only going to look at ordinary annuities, and that means that money goes in at one of the time periods. If we're talking about quarters, and we start talking about how it goes in January 1st, well then January, February, March, we would expect end of March, beginning of April, that should be when another payment would be made. So the R's up here are the payments that are received. And then the numbers that you see below would be what is the time period that this would normally be given interest. Is it quarterly? Is it monthly? What is it? So let's consider an example. Suppose Sarah makes $500 payments at the end of each quarter into a retirement account that pays 8% interest compounded quarterly. Now, some people do this, but most people have a 401, normal people have 401ks, or if you work for a public institution like schools or universities, you get what's called a 403b. Works kind of the same way. But some people are kind of on their own, and they have to figure out how am I going to save for retirement, so you can certainly do that with an annuity. And they found a retirement account that pays 8% interest compounded quarterly. How much will be in Sarah's account at the end of the first year? And what we do is we notice a pattern, because that pattern helps us formulate a formula that we could use for any of these and not just Sarah's specific situation. So the end of quarter one, she puts the $500 in. She's got $500. She waits until the end of quarter two, she puts in another $500. Well, now the first $500 that she had in there has earned interest. But I don't see 8% here. And the reason you don't see 8 is because this was compounded quarterly. So to figure out how much she's going to get for each quarter, we have to take 8% and divide that into the 4 quarters. So she basically gets 2% for each quarter that her money is in there. And then the end of quarter 3, she's putting another $500 in. The money she just put in at the end of quarter 2 has now earned 2% interest. But the money she put at the very beginning has now earned that 2% interest twice. And we see this pattern, and it just starts to jump out at us that if we want to do this, we're probably going to have to start using powers to deal with the interest, because you'll always have the money that was put in as 1.02 to the 0, then to the first, then to the second, then to the third, then to the fourth, based on how many periods those time periods it's been in the bank. And so that leads us to a nice little formula for future value. What would the value of this be at the end of all of the collecting? So the future value is the total value of the investment returned from the annuity with all of the payments and the interest. How much would it be worth? So future value of an annuity, like I said, it's a great formula. It's got a lot going on, is FV. And this R is going to be, what are the payments? What are those periodic payments that are being made? Now, there is something we have to be careful of here. You know, if I saw an I in a formula, there's two things we think of. Imaginary numbers, which isn't going to work here because this is the real number system. We're talking about money here. Or interest. Why isn't it an R? They used R before when they were talking about interest rates, because this one's going to take a little bit of work. Along with the N, notice that's not a T anymore. So the future value consists of N equal periodic payments. Quarterly for 10 years would be 40 of those payments. So we're going to have to do a little bit of multiplication in order to figure out what N should be. How many time periods are we talking about for N? And then dollars at an interest rate I per compounding period. Now that's important because that tells us what we'll do is we'll take our interest rate and we'll divide it by how many times a year this is taking place. And when the payments are being made is really what we want to use for the ordinary annuities. So, not only do they have to account for the money that they owe, but they have to account for the fact that the person is going to lose interest because they can't pay them that lump sum. And this little monster looks intimidating, but you know what? A lot of the times we're just putting numbers in and then we're manipulating with it algebraically, so it really isn't that bad. And down here, we gave you a couple of little reminders that, hey, I takes some work and N takes a little bit of work. You know, there's a formula within the formula taking place here. So calculating the value of an annuity at the end of each quarter year, so every quarter, Emily makes $500 payments into the Lanigan Mutual Fund. If her investments earn 7.88% annual interest compounded quarterly, what will be the value of Emily's annuity in 20 years? That's obviously future value. We want to know how much money she has. So we write down FV equals R and start to think about what all these letters stand for. And then I want to show you, because it's one feature I like of a different book that uses it, in fact, several different books that use this. I really like that those books put that fraction in parentheses. I think it helps a lot when you go to do your calculations, because there's a lot to keep track of. So we want to take that R value, that payment, times this big mass of gunk over here, and we better start to figure out what that big mass of gunk is going to be. So future value equals. Did they mention the payments? What's she putting in? $500 times 1 plus I. Well, now we have to think there's math there. So first thing I have to do is find the interest rate, 7.88, so it's going to be 0.0788. But then I have to divide it by how many times a year it's going to be compounded. Did they say? How many? Quarterly. So 0.0788 divided by 4. And now we have to do a little work for N. Quarterly for 20 years. So you could write down 4 times 20 up here. I'm going to, because I want anybody that's looking at the notes to know where that came from. But most of the time, you can just calculate that in your head and say it's going to be 80 time periods. So that's what we're going to have. And then we have to subtract a 1 from that. And on the bottom, our 0.0788 divided by 4 again. So now, what are we supposed to do? Well, like I told you before, I don't trust the calculator to do all of the order of operations. And this would require at least triple parentheses to get do it right. So what I do is I put my fractions in parentheses, and then I do what we do with any So this is actually going to be the first thing I punch in, is this set that would be in triple parentheses here, the 0.0788 divided by 4. Got that. Now I need to add a 1 to it. I need to raise that to the 80th power. I need to subtract 1. That's all on the top line. And then I need to divide by, parentheses, 0.0788 divided by 4. And finally, take that times 500. And there we are. So, well, I better take this with me so I write it all down, right? The future value is $95,483.39. Like I said, the bank does what's called truncating instead of rounding. So after 2 decimal places, they just cut off all the other numbers. So really, you get $95,483.38. But because we want to make sure everybody just does standard rounding on the test, we're going to leave that. So here's what Emily has to consider. I hope Emily was not going to try to retire after 20 years. Most financial advisors now will advise you that you should have about $1 million in one form or another for your retirement. Whether or not it's part of pensions, investments, whatever it is, if you want to retire. Now, a lot of that is going to depend on genetics. So, how many of you have family members who have lived to be 100 or more? Raise your hand. Okay. How about more than 101? How old? 104. Anybody higher than 104? Well, if that's the case for Emily, not near enough. And that's because, again, it depends on how long you expect to live. I have 2 great aunts that lived, well, actually on both sides. I have a grandmother that lived to be 99. I have 2 great aunts on another side that lived to be 101 and 103. So I'm going to have to consider from age 65, if I retire, to upwards of 100. I need money for all that time. And that's what you have to consider. And you also have to think, am I going to want to travel? Am I going to want to do anything? Or am I just going to sit in my house every day and worry about the price of gas going up and heating costs going up and all of that? So that's not enough, Emily. It's really not. She needs to come up with another plan. And maybe she had thought she would retire early, try for 20 years, but realizes that the money's just not going to be there and might have to work for 30 or 40 years in order to get it there. So that's what future value is for. It's about planning. What's going to happen in your life and how much money will you have? And this next page is, what are you going to spend? Loans and mortgages, talking about present value. So present value is the net amount of money that you put into an annuity, the payments that you make, present values. Banks use the present value of an annuity to calculate the monthly payment necessary to amortize a loan over a fixed number of months. So they're thinking ahead, and they're saying, we're not loaning you this money out of the kindness of our heart. We're giving you this money so we can get something out of it. Now, if we didn't give it to you and we put it into another account, how much money would we make in future value? And if that's the case, then we need to make sure that your payments are going to cover that as we go through this time. To amortize your loan is to reduce or extinguish a debt by money regularly putting aside. For mortgage, it would be your monthly payments. For buying a car, it would be your monthly payments, that type of thing. This says we illustrate this reasoning by assuming that a bank lends you a present value. This is awful, by the way. $50,000 to purchase a house. Not Milk River. $50,000 at 6% to purchase a house with the expectation that you will make a mortgage payment each month at the monthly interest rate of, and this is the 6%, but then of course it has to be divided like we talked about on the last formula by the amount of time periods, which is 12 a year when you go monthly. So 0.005 or 0.5% for each month. Now, the future value of that investment can be found by taking the present value and multiplying that times what interest you would accumulate on that. And the future value of the annuity, we just studied this formula, will look like this. So in order to work this out so that they get the money that they're supposed to get, and you are making your monthly payments, we need these two to equal each other. What it would be worth, and then your payments in the future of what they would be. So in general, the monthly payments of our dollars for a loan with present value, PV dollars, must satisfy this equation. And it looks awful. It really does. So one of the things that they do is they divide both sides by 1 plus I to the n, just to try to tidy it up a little bit, so that present value will be over here by itself. And that's what this says. Dividing both sides by that is going to lead to this formula, which is not quite as messy. And we should talk about the fact my father-in-law must have told us 80 times over the past 30 years about how when they first bought their house, and they live in Coon Rapids, the mortgage payments were going to be $119 a month, and they just did not know how they were going to make that. Oh, $119 a month. Mortgage payments, when you're talking about the homes in Elk River that are probably $250,000, can be upwards of $1,800 a month now. So one of the things you have to consider when you get to the point where you're buying a home is this. You have to have it fit within your budget, but you're also hopeful that you're going to get raises over the years. So when you go to purchase a home, while you want to stay in your budget, you probably want to try for the higher end of your budget, since you're going to be making more money as you go through the years. And that's one of the things you talk about with, they always set you up with a mortgage banker so that you can talk about, okay, here's the payments, this is what we have to make. Would we be able to afford fixing something if something broke? All of those types of things. So with this, Carlos is going out and buying a pickup truck. Oh, I should say with this formula, all of these letters that are used in this formula we have already talked about when we went to future value. So the I is still going to be the interest divided by the compounding periods, and the N is still going to be how many compounding periods per year, and we multiply those two things together. So Carlos bought himself a pickup truck for $18,500. What are the monthly payments for a 4-year loan if you pay $2,000 for a down payment, and the annual interest rate, the APR, is 2.9%? Well, let's figure it out. So the formula is present value equals the payment times 1 minus 1 plus I to the negative n over I. And once again, I do like the other book's way of putting the parentheses on there, and it shows what we're supposed to be doing. So present value is how much he paid for this in order to drive it off the lot. Now at first you say, well, it's $18,500. That jumps out at me. But when he left the lot, is that what he owed? How much did he owe? Minus the 2,000, yeah. So he really owed $16,500. Now here's a new one. We need to know R. That's what we're trying to figure out. We're trying to make sure that we're making payments that are within our budget. So there's our payments. 1 minus 1 plus, and our interest rate, but per time period. So we've got 2.9%, 0.029. But when are we making these payments? Yeah, car loans, home loans, all of that stuff. Mortgages, I guess I should say, since that's a specialized name for home loans. Always going to be in monthly payments. But then we need to know how many payments are there going to be for the whole thing. You see it? How many years? How many payments each year? So again, I'm going to write 4 times 12 up here so that people can follow the notes, but we would probably just slap a 48 up there, so negative 48. 1 plus I, I'm missing a set of parentheses here. Green. And down on the bottom, we're back to our 0.029 divided by 12. Now, different methods you'll see used depending on who you have that's teaching you about this financial business. Some people like to multiply by the reciprocal. So some people would say, I'm going to take $16,500 And I'm going to multiply that by 0.029 divided by 12 over 1 minus 1 plus 0.029 divided by 12. That's not readable from the back. Negative 48. And get the answer. I like to make sure that we're using past skills. We already know how to punch something like this in. We just did it when we were talking about future value. So what I would do is punch this in exactly the same way as we did the other one, and then at the end I'd just take 16,500 and divide it by my answer. That way I don't have to try and do anything fancy with it to find R. So we start with the innermost parentheses, which are going to be right up here. 0.029 divided by 12. Add a 1. Raise to the negative 48 power. Take 1 minus that answer. Divide it by, parentheses, 0.029 divided by 12. Oops, the 9 first. There we go. That there. And then take 16,500 and divide it by that answer. So $364.49. So we've got this money, this $364.49, and I think, well, I just rounded up a penny. So in the end, won't I have a refund coming to me or something? Well, what they usually do is they'll have you pay this for the first 47 months. And then they ask you to call them and find out what that final payment should be, because it will be a little bit less than the 48th month. A little less. So especially when, we're rounding up as to our payment, over the course of those 48 months, we're going to be paying an extra penny in a few of those months. And so that should make that last payment a little bit less. Now, some banks will accept, and in fact, most of them will accept, what are called principal payments, which means after 10 years, you've gotten some big raises at work. And initially, this $364.49 was really hard for you to pay every month, but now you've got extra money. I guess the best financial advice out there right now is not to pay down the principal on your home. And that's because home loans are at record lows. But you should pay off faster than normal. Things like your automobile loans and or credit card debt. So when you're making extra money, what you can do is you can send an envelope to the bank and say, I want this check to go to principal. I want this check to take just money right off of the money that I owe you. This is not to pay on the interest. This is to pay on the principal. Then by the time you get to the end of those 48 months, you might not have anything left to pay, and you've paid less interest. Because the more you can bring down that balance on your principal, the less money there is to pay interest on. So that's another thing that financial advisors will tell you is a good idea to do. But like I said, not on your house payment. House payments over the last 10 years have been at record lows. Right now, they're not at the lowest they've ever been. They're at 4.25% for the prime rate. But homes are considered a huge investment. And because you're not going to save a ton of money by trying to chip away at the value of your home, go after the other stuff first. So I went a little bit outside the box because you guys are getting to the age where hopefully you're starting to think about stuff like that. I'm going to have to buy a vehicle. I'm going to buy some place to live, and calculate the future value of annuities and find the monthly payment or a term of investment. That's what we did today. So basically, I need to know how you feel with these last two formulas. And does anybody have a question on these two formulas? Nobody today has asked. Do we have to memorize these for the test that we're going to take at the end of this week? No. You don't have to memorize these for the test you're going to take at the end of this week. fact, I don't know why we were so generous, but you don't have to remember the stinky green shampoo formula. We even put that on there for you. So we put acres on there, we put the compound interest on there, we put these two formulas, we put that I equals R over K, and that N equals K times T. I mean, they're given to you. So if that's the case, give me your comfort level working with these two formulas, with 43210, and feel about 2 millions today. They're excellent formulas, by the way. It's one of those things that most people don't check, because when you do get a loan, they have a loan officer. And so you expect that the loan officer knows exactly what they're doing. Well, we all know, everybody's human, everybody makes a mistake. Just last night, we went to Subway for dinner, and I had a coupon for a free 6-inch Subway from the past. And went up there to pay for my sub and gave him the coupon, and had some soup and a drink. And he rang it up, and he said, "That's $9.58." And I said, "No, I had a coupon for the free sub." And he said, "Yeah, and now it's $9.58. I already put the coupon in." I said, "How expensive is your cup of soup and your drink? Because I don't see a cup of soup and a drink coming out to $9.58. And he went back and forth with me for a little while, and he said, "Well, isn't that sub yours too?" No. So he had 2 of them in there. People make mistakes. This would be a little bit maddening to have a loan officer make a mistake on something like a major home loan. But you do need to check it. And so